Let's talk about the unsung hero of the power grid, a device working tirelessly just out of sight.
Okay, so what's the single most critical device on the entire power grid? The absolute linchpin?
It's not what you think. It's the humble transformer. This unassuming box is the grid's MVP.
So what's the magic inside? Well, it's a masterclass in efficiency, all thanks to some beautiful physics. The magic starts right here. In a balanced system, those three magnetic fields just cancel each other out. And because of that perfect balance, you need less steel. That makes these things smaller and way more efficient. But that balance is super delicate. Even a tiny voltage spike can cause a huge damaging current surge. So how do they talk to the grid? They actually use a special language of different electrical connections. The two main dialects are star and delta. Star gives you a safe ground, delta traps rogue electricity.
And the Zig-Zag connection? That's a specialist for handling really unstable and unbalanced electrical loads.
This brings us to the vector group. Think of it like a transformer's unique fingerprint. It's all about timing. And to make sense of this, engineers use a really clever analogy, a simple, familiar clock face.
Here's the key. The high voltage side is always set to 12 o'clock. That's our reference point.
So if you see die 11, it just means the low voltage side is at the 11 o'clock position. Simple. And this timing is absolutely critical when they have to work together. It's a high-stakes team effort. And I mean high stakes. Get this wrong, and you're looking at catastrophic, explosive failure. No joke. To avoid that, there are 4 golden rules. Everything has to match: voltage, vector group, impedance, and phase. Now, these things are built to last for decades, but they still need regular health checks to stay in shape. Engineers do what's basically a blood test, checking for gases that signal an internal fault is brewing. One of its biggest stresses, though, it's that startup. The initial inrush of current is absolutely massive. That surge is why they need specialized heavy-duty gear just to handle that initial power-on stress. So, next time you flip a switch, maybe you'll think of the silent guardian managing the flow.